Today we're starting a new unit on solving systems of equations. So make sure you get your date and your page number. We're going to solve this by graphing, so you're not actually going to learn anything new. Make sure you get your learning target and all this stuff down. You should have this on your own set of notes. And we're going to talk about, first of all, what a system of equations is. Basically, a system of equations is just a set of more than one equation. So instead of dealing with one line at a time, everything we're going to do is linear, which means a straight line. Instead of dealing with just one line, we're going to deal with two. Alright, so a system of linear equations is formed by two or more equations, and for our purposes in Algebra 1, we're only going to use two. Okay? And they're all going to be linear, which means all straight lines. You can have system of equations where they're quadratic, cubic, one's linear, one's quadratic, but for Algebra 1, we're just going to do all linear, and it's going to be only two at a time. The solution to the system, so if I ask you to solve the system, what I'm looking for is an ordered pair that makes both the equations true. So basically where you have one solution. And when you're doing it with the graph method, that would be the ordered pair where they cross. So let's look at our example 1. I'm going to graph both these lines. First one right here, it's written in slope-intercept form, y equals mx plus b. I'm going to go ahead and graph line 1. And in line 1, I have a slope of 1 and a y-intercept at 2. So my ordered pair, my starting point, 0, 2, and my slope is 1 over 1. So think back to last semester. So I'm going to start at the ordered pair 0, 2, my y-intercept, and then from there go up 1, right 1, up 1, right 1, up 1, right 1. And again, you just draw a line between the points. You don't have to make all these dots, but the more accurate your line is, the easier this is going to be. Just draw a line between your points, and that is line 1. Now we're going to work on line 2. On line 2, it's in slope-intercept form. 0, negative 2 is my y-intercept, and the slope is 3 over 1. So from there, I'm going to start at 0, negative 2, and then I'm going to go up 1, 2, 3, right 1, up 1, 2, 3, right 1, up 1, 2, 3, right 1, and then draw my line between those points. Notice when I do that, these two lines cross at that ordered pair. And where they cross is your solution. So my answer to this question, the solution to this system, is the ordered pair 2, 4. So that's my answer, 2, 4. It's where the lines cross. Let's do another example. You don't have to write this one down, it's not on your slides, but I just want to give you one more. Alright, so here's the one we're going to try now. Let's start with the first line. The first line, my y-intercept is at negative 3, and my slope is 1/2. So from there, I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, and this is my first line. So draw a straight line between all those points. Oh, that was not a straight line. Oh. Then I'm going to do my next line. My y-intercept starts at 1, 2, 3, 4, 5, 6, 7. And my slope is down 1, 2, 3, right 1, 2, 3, 4. Down 1, 2, 3, 1, 2, 3, 4. And here's where it crosses. So you can see when you draw your straight line that my solution is right here where they both cross, and that's the ordered pair 8, 1. Now let's look at example 2. If I solve this system, let's start by graphing line 1. My y-intercept is at -5, so I'm going to start down here. And my slope is up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. I'm going to draw my straight line between all my points. And then my next one, my second line. It starts at 7. And from there, I'm going to go up 1, right 2, up 1, right 2, up 1, right 2. And what I want you to notice is they're never going to cross. So in this case, there is no solution. And that's because they're parallel lines. And the definition of parallel lines is that they never intersect. Well, the definition of a solution to a system of equations is where they intersect. So therefore, there is no solution to this system because they will never actually cross. Example 3, I want you to try on your own, and we will discuss it tomorrow in class.